Hello, everybody. My name is Jim Walgenbach once again. If you were here yesterday, you recognize who I am. If you're new here, as I indicated, I'm at North Carolina State University, and I'm project director of this SCRI program. And this is our last stakeholder advisory panel meeting of the project. And in day 2 here, we're going to be continuing with our report or accomplishment section, and then we're going to move into a stakeholder interactive session. So I encourage everybody, even if you're not a stakeholder, to stick around towards the end and provide your input. I'm going to share just a couple of slides for housekeeping chores here. Make sure I have this. There we go. So as I went through yesterday, I indicated the agenda. We have basically 4 different sessions, and we went through 2 of them yesterday, which were the landscape ecology and biological control accomplishment sections. Today, we're going to continue with the management strategies objective, along with the economics and outreach components. So there's 6 presentations we want to complete this afternoon, and then that'll be followed by the stakeholder input session, which Nick Wyman of Oregon State University will be running. So this shows you the agenda up here today. Again, we're going to begin with Tom Kuhar in a little bit here, talking about insecticides, and then it'll finish up this section with Deb Grantham talking about the outreach component. During these accomplishment report sections, these first 6 presentations this afternoon, if you're interested in asking questions, we ask that you submit them in the written part or in the written option below, and use the Q&A option, not the chat box. You want to reserve the chat box for if you have maybe technical issues or private conversations among people. And we will have people that are scanning the Q&A option for so that we're aware of questions that may be asked, and they will all be answered during the discussion section at the end of the section. So if you have a question during somebody's talk, write it down, and we'll get back to it at the end of the session. During the stakeholder input session, we will encourage more live questioning by people. And if you want to ask a question live, use the raise your hand option on the bottom of the screen to let us know that you would like to talk. You'll gain access to the speaking room. Also, throughout most of these presentations, there's going to be some polling questions. And matter of fact, during the interactive session, there'll be a lot more. And you'll know when these are going to be asked, because when we come up, you're going to see a slide like this at the end of each individual's last slide of their presentation. They'll say, it's time for a few polling questions. And at that time, they'll be put up on the screen. We'll give you 15, 20 seconds or whatever to provide an answer. And then we'll provide a quick response, or we'll show you what the responses were from everyone at the end. Now, to make sure everybody, if you weren't here yesterday, everybody is aware of how to use this, we're going to do a couple of practice polling questions. Actually, just one practice polling question. The other one is a lot more important. So we'll see how things compare today with what they were yesterday with our practice one. So what's your favorite specialty crop to eat? You got all the ones that are potential pests of, or potential hosts of brown marmorated stink bugs. So be interested in that one. And then the one down below, this is important that you answer this correctly. It's to classify your responses into different groups at the end of the program, so that we can separate how a stakeholder advisory panel might differ from a co-PI of the project, or a Bmsb researcher, extension educator, government regulator who's part of the Bmsb community, but not technically associated with this project. How are we doing on responses there?
Got about 83% after 1 minute.
There seems to be about a 15 to 20% portion of people that just don't want to participate in this. So I don't know if we can put any carrots out there for them or not. Okay, maybe we can see what the favorite specialty crop is. Oh, peaches. Well, it's apple and peaches again. Sorry about that, Nick. Hazelnut's pretty far down the line. Okay, and we got a good mix of people here. Okay, we're just a couple, pardon?
There is one question from Don Weber for you. And it says, Jim, will you be sending out the grant no cost extension by email?
I won't be doing that, but you should hear from your institutional leader shortly. I know yesterday Larry Good indicated that Michigan State was just recently notified that the no cost extension was approved. I wasn't aware of that. They didn't copy me when they sent it from NC State. So you should be hearing that. And then hopefully that can filter down from your institutional leader to the individual co-PIs. But just to quickly summarize it again, there is a no cost extension that's going to be for 1 year. It doesn't provide any additional money, but due to the pandemic, the SCRI project or program found a way to be able to extend it at this point in time. So again, no additional money. I think what's going to really revolve, or what's going to end up, is it's just providing an easier way or more relaxing way to close out accounts at the end of the year, so, or at the end of the project. So okay, let's begin the program for today if there's no more questions for me. Good. First presentation is by Tom Kuhar of Virginia Tech, who's going to be talking about insecticides, current options for Bmsb control, impacts, and the future outlook. It's all yours, Tom.
All right, thank you, Jim. I'm assuming everyone can hear me and see the slides. I don't hear any no's. So anyway, yesterday the later part of the afternoon, we heard a lot about biological control. Some fantastic work and some great things on the horizon. But now it's time to hear from our resident nozzle head here about the insecticide component, which is also part of IPM program. So there's been a lot of insecticide work that has been done as part of this project. It's definitely over 80 papers. This was when actually summarized a lot of the research that was done in North America with Dr. Kathy Kaminga, and we kind of did a synopsis of these studies, but there's been far more done. I will point out some labs that were very active in this over the years. Tracy Lesky, Greg Krachek, Peter Jensch, Ann Nielsen, George Hamilton, Jim Wagenbach, and my lab, and there are others. But I've pulled some information from some studies that were done from all of those. And again, there's a review article that was written not too long ago to at least bring you up to speed. So a lot of laboratory and a lot of field studies. And fortunately, a lot of them pointed to the same thing. It wasn't conflicting studies. Most of them showed a lot of the pyrethroids being very, very efficacious. And several of the neonicotinoids, dinotefuran in particular, also very, very effective at controlling this bug in a lot of different cropping situations. So that was good. We had something. We have insecticides that appear to work from the research. There are other insecticides in the organophosphates and carbamates that also work well on this bug, but the problems with those is that some of their crop registrations are limited. Some of these organophosphates are going away, likely because of regulatory, like chlorpyrifos, for instance. So won't have a lot of discussion of those. We're probably dealing with growers applying pyrethroids and neonicotinoids. The good news with pyrethroids is that there are a whole slew of them. There's more pyrethroid insecticides out there than any other class of chemistry, and these are the ones that work the best. So that's good news from a grower standpoint with regards to cost and likely having something that might be registered on the crops that's going to work. So that's a good sign. Another thing I'll point out, I'm not going to go through all those studies, of course, because the conclusions are all the same, but there is some work that was done with this paper here looking at the residues. So we know which insecticides work, but how long do they work? I think this was a really good piece of work of showing that after about 3 days, you're getting a drop off in that efficacy. And that's something that growers are definitely concerned with, because when you get these bugs that are moving in, they just seem to be coming in from a border crop, which occurs with this. You may need multiple sprays, and especially during that heightened period. They also, Tracy Lesky and her group showed that the adjuvants didn't increase that residual activity. And another important thing is that the bugs earlier in the season, these adults that overwinter and then come on early, it's not all crops, but some crops may get that first wave of them, that those are actually easier to kill than the ones that are the offspring of that first generation that are going to occur later in the summer. So that's interesting to know. But the sad news is when we get attacked a lot on our crops, it's probably those mid to late season adults that are harder to kill. So good information. So that was the research end. So I was curious, what are growers actually using? We know the research. So I've actually pulled several of my colleagues around the country and basically asked them, what are your growers using after this? Are they doing the job according to the growers and from what you've seen? And are you seeing any problems, any like secondary pest outbreaks, any other non-target impacts? So real simple survey. Got a decent response. We had 22 respondents representing 16 states. So it's across commodities, it's across geographic regions. So that was important. And this is the percentage of the respondents that said that this is what their growers are using. And Donateffuron's a neonicotinoid. By the way, the neonics are in blue, pyrethroids in red, and yellow is a couple of the others, methomyl and sulfoxaflor. But what we're seeing here is a lot of red, and blue. So the growers are using what the research has shown are the best materials, and just that there's a heavy use of two chemistries. That's the big point, and that is what growers are doing. Are they working? And this is really good news. A really high percentage, 85 or 90, said yes, they are working, or moderately, they're working and moderately, and no one said that they're not working. And so that's really good. From a grower standpoint, we do have tools that seem to work and they are working, but you got two classes of chemistry. So there's some potential problems. And the first being potential insecticide resistance could build up. You keep using the same chemistry. That's been known to happen in a lot of insects. And then two, these aren't the safest classes of chemistry. There's potential non-target impacts, and they're certainly maybe not the most compatible for IPM systems. So that's kind of our current situation. With regard to the resistance development, we've not seen or heard of brown marmorated stink bug, at least in the US, developing resistance. But I will say that a group of us have published this paper. We've gotten some baseline toxicity with bifenthrin, one of the pyrethroids, and thiamethoxam, one of the neonics. And I think that's going to be potentially useful going forward. I could see, 10, 20 years from now, if these two chemistries are still the predominant ones, have things changed? Are we starting to see less susceptibility with this heavy use of these products? So we've got some baseline work. I won't get into what the LD50s are, but we have it. That's the important thing. Second part now, secondary pest outbreaks. Yes, the survey respondents pointed to a lot of things, some insects I hadn't even thought of, like on the top, you got a Spodoptera, a yellow striped armyworm. I think same would be the case for beet armyworm in the same genus. But you get a lot of these things that are considered secondary pests, these scales, these mites, aphids, a lot of things that are resistant to pyrethroids. And when you spray them, you cause them to reproduce and you kill all the things that are eating them. So really common situation. And the respondents definitely said there's just a lot of examples of pests that we've got to deal with now because we're spraying these chemicals that we probably don't want to be spraying. So That's not good for IPM. So we can do better, or hopefully we're going to try to strive to do better. I'll show you a trial, just an example of these secondary pest outbreaks, one that I'm intimately familiar with because I see it almost every year. Brown marmorated attacks peppers, loves this among the vegetables. You can see the feeding injury that it does. We get these kind of later in the summer, at least in Virginia. So we spray trials for the stink bug to try to protect it. And here's an example of a spray trial that had 3 pyrethroids, bifenthrin, lambda cyhalothrin, and permethrin against a control. And we did reduce stink bug damage about 60% But look at the green peach aphids on the far right. That's kind of the point of the slide. So yes, we can reduce stink bug damage with 4 sprays, but we've caused a green peach aphid outbreak. It's pretty clear right there. And it's pretty clear every single year that we do it. We get this. This is green peach aphid, by the way. And when it gets out of hand like that, that's what you get for your peppers. That's honeydew that has dropped onto fruit and then sooty mold growing on it. And you thought having a little stink bug injury was bad, then you got to deal with this. So it's just an example of that's not a sustainable, very IPM compatible program right there. So, okay, what are some alternatives? What are some other ways to go? If you have vegetables, for instance, we've shown that the neonics are very effective. And one thing that you can do with neonicotinoids in vegetables that have like drip chemigation is you can put neonicotinoids down through the drip system. And we were really curious. This was Jim Wagenbach, some data from his lab and my lab. And we were curious, will that work against stink bugs? Because, when it's put it through the drip system, it's moving up through the roots and through the xylem, but stink bugs are attacking the fruit. So that's not going to work. Well, it actually did work. And some research has found that even though stink bugs are primarily feeding on fruit, that they have to hydrate. The nymphs are actually tapping into the plant vascular system and taking a drink. And I think that's where we're getting a lot of them. We're wiping them out when they're tapping into that vascular system. And so we actually reduce damage significantly on plants like tomatoes and peppers with putting neonics through there. So, that's one crop where maybe you could probably do something a little different. As soon as we did that work, all of a sudden, neonics became public enemy number 1, and the regulatory action started on them, and concerns of their putting too many neonics in the environment and impacts on pollinators. And it was like, wow, we got something. Well, maybe we won't be putting that up on the billboard. So anyway, neonics may not be the answer either in all systems. So we're still searching. We've got to find some less disruptive insecticides. And there was a recent paper, Dalton Ludwig out of Tracy Lesky's lab, showing TJ. Some good news with some insecticides are that when TJ is inside the egg mass, that it seems to be pretty protected and not killed off by a lot of these insecticides. So yes, if you hit a adult wasp with any of these insecticides, you're likely going to wipe it out. But the good news is it can probably survive some sprays when it's in the egg. So a lot more of that kind of work is going on and probably still needs to go on. But we are definitely searching for more IPM compatible insecticides. So what's one option? Well, insect growth regulators, particularly those that are chitin biosynthesis inhibitors. So these will prevent the insect from making its exoskeleton or its cuticle after it molts, and then the insect dies. And some compounds that do that are novaluron, diflubenzuron. We tested these back in 2012, and they are very good on nymphs. They will control nymphs. When they try to molt, they're not going to make it. They're going to die. There's no activity on eggs, no activity on adults, or on their egg laying or reproduction. But it's an angle here that if you are targeting nymphs, and you can target the nymphs, that you've got something that's a lot more IPM friendly. I will mention that there's some work in Europe, in Italy in particular, to triflumaron, another same type of an IGR, is working very well on nymphs as well. Now, Ann Nielsen mentioned her model of predicting nymphs or predicting the life stages. So if we could put 2 and 2 together, where we know we're going to get predominantly nymphs, this could be a time where you could switch to an insecticide like this that is kind of just active on the nymphs. What are some other insecticides, Jim? If I'm starting to go a tad bit, kind of give me a wave of the hand or something, but I'll keep rolling here. Some other classes of chemistry that have been looked at, and where are we at with some of these? Sulfoxaflor is, similar to a neonic, but maybe a little bit safer on some of the non-targets. It's less toxic. It's not completely safe for things like pollinators, but it might be a better option, more IPM compatible. But does it work against the stink bugs? I'll address that in a second. Another one is Harvanto, flupuridifurone, the active ingredient. This is another one that's kind of neonicotinoid-like, but not exactly, and it's not considered a neonicotinoid, and it's got a lot more favorable attributes with regard to non-targets, particularly bees. So we've got some things that might be a little bit lighter, a little more IPM compatible, a little more compatible with pollinators, but do they work? And I'll get into that in a second. Another one is Harvanto, which is active ingredient cycloniliprole, and this is a relatively newer diamide insecticides. Diamides as a whole don't work well against stink bugs, but this one, if you had to pick one, has the most activity on stink bugs among the diamides. It's not saying a ton because the diamides aren't very good on them, but this one, especially nymphs, it's got some decent activity, and again, it might fit better in the IPM program. So these are
2 minutes, Tom.
Okay, thank you, Jim. And belief is another. This is one that affects the cortitonal organ. It kind of affects just hemipteran insects. So we've got a lot of trials, but I'll show you this one because it's got all of those products in one trial, and these are the results we got. It's in tomatoes 2018. You're looking at proportion of the fruit that had stink bug injury, and I think the bottom line here is that Closer performed pretty well. Harvanto, belief, not bad. Harvanto, you definitely needed a higher rate if you're going to get anything, and it didn't look like it competed with the other ones too well. So I need to get into what are some options for organic growers in these last couple of minutes here. And boy, it looks rough. We tested a ton of the products that are naturally occurring organic products, and just the bottom line in lab trials and field trials, they didn't work. This table, if you want to look at it later, nothing worked of any of those. But we did try kaolin, which is basically putting out a fine particulate powder, just a inert clay-like powder. And you can put these down to reduce sun scald injury on fruiting vegetables and tree fruit. Stink bugs do not like it. They do not like walking on it. They won't feed on the fruit this is applied to them. So here's some results of it. The kaolinite is in the gray, and you can see the proportion of damaged fruit. I think this one was peppers. We have it on tomatoes as well. So it actually provided very good control. You have to keep applying it after it rains, but it is something for organic growers. So in summary, we got the pyrethroids, neonics. We got some baseline data. We've got a few insecticides to look at that are more IPM compatible, especially on nymphs. We've got kaolin for the organic growers, but it's time now for maybe a couple more polling questions. So thank you, Jim.
Thank you, Tom. Very good. So David, you can show those results when you get an opportunity. I'll transition here to the next presentation.
Okay, sounds good.
So our next presentation is going to be talking about the evolution of pheromones and the evolution of pheromone use for brown marmorated stink bug by Tracy Lesky of USDA ARS.
Thanks, Jim. Let me see if I can, oops. I'm having to go through the browser, so it's a little bit odd. Let me see if this one is correct. Which one are we seeing? We're seeing your screen, aren't we? All right, you're muted, Jim.
No, this is the correct one.
Okay, great. Okay, thank you. Okay, so I'm going to talk about pheromones discovery, commercial development, and uses. So the thing to keep in mind is that when Bmsb first emerged in 2010, we had no management recommendations in any cropping system, and hence the work that Tom just covered, but we also had no monitoring tools to enable growers to make informed management decisions. And so, that really became the primary focus in the early days, just trying to develop tools that can provide growers with the opportunity to get away from these calendar-based sprays and really make management decisions on presence, relative abundance, and seasonal activity, and as well as countries that may have been interested in detecting, excluding, or eradicating. So back in the early days, we had this system, and this is how we began. We found that a large black pyramid, a trunk mimicking stimulus, served as a good trap. We also know from the work from Jeff Aldridge and Ashot Krimian that methyldecatrienoate, which is a pheromone produced by another Asian stink bug species, Plaudia stahli, could serve as an attractant. And just based on the design of this trap, we knew that the pyramid provided a mechanism to funnel bugs into that collection device, and we needed a kill strip. And that deploying traps at the edge of orchards or other vulnerable crops were good because of the dispersive nature of the insect. However, we also learned pretty quickly that MDT had some serious limitations, namely that it was not attractive to adults until the late season. So this is just a sample of the kind of captures we would see in traps during the early and mid-season in a peach block, with most of the captures occurring after harvest, so not very helpful. Fortunately, led by Ashot Krimian, we were able to identify the Bmsb aggregation pheromone, and the first positive results came in the fall of 2011 with, as you can see, that number 10, which was what we referred to the compounds as at that time. Additionally, as we continued on, we found that this two-component lure, the SSRS and the RSRS isomers of the Bmsb pheromone, along with methyldecatrienoate, could serve as a very good pheromonal stimuli source. In fact, when you combine them, you get a synergistic response, which means 2 + 2 no longer equals 4, it's more like 8. But one of the things we wanted to do, based on some of the work that we had done in ARS, was to really validate this across the country. And this is where these large multidisciplinary and multi-state teams are really important. And so during the first SCRI, we validated these results across the country, asking if we saw a synergistic effect by combining pheromone plus MDT season long, asking how attractive was the pheromone alone. We knew it was attractive season long to both adults and nymphs, but we wanted to see how attractive it was when we combined it with different loadings of MDT. And so these studies were conducted across the US. We had a number of collaborators. And what we were able to show was for both adults and nymphs, season long, early, mid, and late, by combining those pheromonal stimuli with the MDT synergist, we really had a good combination going forward. This led then to where we were with Bmsb SCRI2, which we had a number of questions around, can we really improve our trapping system, asking what is the most sensitive and commercially available cost-effective trap design and lure formulation. With these systems, can we reliably detect low populations? Do traps work reasonably well in different geographic regions? And can we detect, nymphal presence, sort of the idea of reproductive populations with simplified trap designs? And then asking the question, what is the size of the area sampled by the most effective trap? This led to a lot of studies with a lot of different trap designs. You can see a number that were evaluated by many collaborators here in the US and Europe, as well as experimental lures, where ARS provided commercial companies with sort of starter material, and they created lures that many of us evaluated. And so from all of this work, we really then sort of started to zero in terms of trap design and lure formulation. And so during the second period, the SCRI2, we had an initial study in the Mid-Atlantic where we compared two trap designs, the Black Pyramid trap and the ground deployed sticky panel. Both of these are similar in that they do provide an upright visual stimulus, but obviously the capture mechanism and sort of the killing agent or retention mechanism are different between the two. We also had 2 companies who agreed to formulate lures based on 1x and 4x loadings, a standard sort of monitoring dose versus a higher dose that you may want to, sort of increase the sensitivity. And we conducted this work in 12 locations in the Mid-Atlantic. What we found was that trace-based lures did outperform AgBio across the board, but we also began to see that these sticky traps appeared to show promise. All of the traps detected Bmsb at low density sites. You can see these are divided into low, moderate, and high population pressure sites. And we also saw that nymphs were detected on both trap designs. So this was encouraging. And the other important point of this was that we also wanted to know, we know that pyramid traps capture more, but the idea of a trap is that it really does measure the relative population density and sort of those ups and downs in terms of seasonal captures. And so we looked at correlations between pyramid and panel traps for both adults and nymphs season long with both high and low dose lures. And you can see in every case, we did see a significant correlation. So they are reflecting the same seasonal patterns and relative densities. This then led to the entire SCRI team conducting a very large trial across the US in these 5 different regions, the West, the Pacific Northwest, Great Lakes, Mid-Atlantic, and Southeast. And so in all, we had 18 states and 5 regions and 118 sites. And in this case, we were just comparing the pyramids versus the panels at a 1x monitoring sort of loading, and we measured season-long captures from late May to early October. And there were 2 key takeaways and 2 ways we really looked at these data to see if these traps were effective, and lures, I should say. One was to look at seasonality, so sort of early, mid, and late season, what did we see? Well, not surprisingly, pyramid traps captured significantly more adults and nymphs than the panels season long, but just like we saw in the previous study, we saw significant correlations between pyramid and panel trap captures, indicating they were reflecting the same seasonal patterns, except in the early season, of course, when we have very few nymphs. The other way we looked at this was to look at low, moderate, and high pressure sites. And again, compare pyramids versus panels, not surprisingly, more in the pyramids than panels. But again, significant correlations indicating that they were still reflecting the same relative densities and patterns of capture, which was good. We've continued to work through sort of trying to also increase and refine the efficacy of our pheromone lures. And this paper was just recently submitted. It has a large number of our SCRI2 team, as well as European colleagues. And we, in this case, worked with a commercial company and looked at different loadings of both pheromone, MDT, as well as another attractant, EDT, to see how these lures would perform. And we also had some different dispenser substrates. What we found in this paper was that the dispensers that we're currently using are probably the most effective, but the cost of lures can be reduced by decreasing the amount of pheromone just because it's more expensive to synthesize and increasing the amount of MDT without sacrificing attractiveness. In other words, you can play with those ratios and get essentially the same kind of captures without, but also without increasing the cost. Excuse me. So that was also going on. Additionally, my lab, we try to use some of the work that was pioneered at Michigan State by Jim Miller to try to define the trapping area of a pheromone beta trap, because this is also really important to this. And so there are kind of 3 pieces when you think about trying to create a trapping area, which is essentially the circular area around a trap over which a single trap can reliably capture insects. The plume reach, which is the distance from a beta trap that elicits a behavioral response from an insect moving randomly. The maximum dispersive distance, which is basically the longest distance from which 95% of the population can reach the trap. And these combined create the trapping radius that you can then, of course, use the area of a circle to define trapping area. This is based on a mark, release, recapture study where we mark and release insects at longer distances from a beta trap, in this case, a banded panel trap. And so we did this both in open fields as well as apple orchards. And what we found, not surprisingly, is, and this has been found for other insects, is that the estimated plume reach is short for both adults and nymphs. But the thing you have to remember is Bmsb are very dispersive, and that increases the area over which a single trap is effective. So with that maximum dispersive distance, you can see that in an open field, a single trap can reliably capture insects over a 5.5 hectare area. But when you have a cultivated crop present, this is competing with this trap, and so it's reduced to about 1.7 hectares. And so from this work and the way we've been spacing our traps apart, about 50 meters apart along orchard edges, that's probably okay in terms of reducing competition between traps, but reliably capturing individuals. One of the things that we've been interested throughout this project is trying to see if we can also develop reliable thresholds as we did with beta pyramid traps. And so over the past 4 years, we've been trying to develop one for apple again and use it as a model system, and really lets us know are the captures, do we understand what that biological information means, and can we use it to make management decisions? So these are just some data I just wanted to give you a quick peek at based on using sticky panels and a number of different thresholds over the last 2 years. Unsprayed apple blocks, 4 nymphs per trap, 4 adults per trap, 1 adult per trap, always sprayed. And so this is the number of spray events, and this is the injury at harvest. And what we've been able to show is that we've been able to reduce the number of sprays by greater than 50% when we use this 4 adults per trap threshold. And we've also gotten injury to where it's reasonably close to blocks that are sprayed weekly. So we think we're getting pretty close with this particular threshold, but I also think it's a good approach for creating thresholds, this sort of forward-driven experimental approach. In terms of next steps, well, at this point, I think we can conclude that we have very good commercially available pheromone lures and 2 types of traps, clear sticky panels and pyramid traps, that have been widely evaluated and work well in terms of season-long relative captures and reflecting relative densities for both adults and nymphs. We have the capacity to create decision support tools. But as Tom mentioned, we really start to need to think about the next steps, which is in integrating biocontrol with these other IPM tactics, which I'll talk more about when we get into the area-wide project. So I think I'm on to my last slide, Jim, if we want to do polling questions.
Okay, thank you, Tracy. You came up short on time.
Wow, I was probably talking fast.
Well, as long as I have that opportunity, let me ask you one question.
Sure.
About the trapping area of a trap. You know, for instance, like 5.5 hectares, and that really is takes into account the dispersal area of the insect.
Right.
So
right.
What's the probability? So I guess it's 95% probability that it will intercept that within that 10-meter area of the lure to become attracted to it. But isn't that a function of time? So
yes.
So what is the time component with that?
So we get most of those captures when we do those mark release recaptures. That's over about a 48-hour period, Jim, and that's what that's essentially what we use to calculate those trapping areas. So
if you're just checking traps once a week, it's probably even a bit larger than that, correct?
I'm thinking it through. Larry, what's your take on it? I guess it would be, because if they're moving randomly through the environment, you could have more individuals encountering that trap over time. But the trapping area still shouldn't change because it's based on sort of its area of act. So what am I trying to say? Any insect that's foraging in that 5.5 acre area, there's a possibility of capturing it. A reasonable possibility of capturing it.
So
I
Jim,
think it's
definitely time dependent, and you just have to define in your experiment what you think the lifetime of searching of that insect is.
Yeah.
I don't know Bmsb, but for calling moth, we had it pretty much down.
What was yours for codling moth, Larry?
Probably between 4 days, 4 and 7 days.
in our mark release recaptures, we weren't capturing anybody after 2 days in those
Yeah.
trials, more or less.
Sure.
Yeah.
Okay, we
Oh, that's your
can
time.
probably move on
Yeah.
at this point in time. Okay, the next presentation is by Jim Hepler of Washington State University. He's going to talk about attract and kill technology, progress, and future directions.
Okay, I will share my screen now. All right, that show up okay for everyone? Okay, so as a quick overview, today I'm going to be going over what the Beers Lab has been doing for attract and kill using the insecticide netting in mid-Columbia fruit orchards. That's kind of our closest area of ongoing economic damage that's occurring from stink bugs. And that's part of my dissertation research. And then I'm going to be briefly going over and summarizing the research from a number of other labs, mostly in the Midwest and the East Coast. All right, so you guys have seen this before. If you've been to any of my other talks, I came up with an idea for a larger panel trap design that incorporates retention tubs and these integrated netting flaps. This is made of insecticide netting. It's baited with the pheromone lures as usual, has these retention tubs at the bottom. And it started out as a pilot study in 2018 just to kind of see if we could improve upon the classic ghost trap design. So we dinked around with it a little bit. We got some interesting results in 2018. They weren't statistically significant. So we repeated it in 2019, but I get ahead of myself. So anyway, here's a close-up of some of these design features. The sewn-in arrestment flaps, this was an idea that came from Adrian Marshall's PhD research, where he was looking at these netting barriers, and he found that the negatively geotactic behavior of stink bugs when they fly in and encounter an obstacle and then they climb upwards, he integrated these flaps into his big barrier nettings and found that they did seem to catch stink bugs, and we'd find them trapped in these flaps and dying. So he also incorporated an insecticide netting lining to that and some of his work. And so I took that idea and I ran with it to make a Bmsb trap. And some of these other features seem to be supported as being good by other research that I'll cover. So as I mentioned, the pilot study in 2018 gave us some interesting results, but they weren't statistically significant. So we scaled it up to do some confirmation in 2019. And this was an exercise in the concept of overkill is underrated, because this was a Herculean experiment to run by myself 400 or 200 miles away from Wenatchee. So anyway, it was interesting. We did these blocks as replicates, and we divided them up into ghost trap, border sections, poncho trap, and then no attract and kill. The grower standard was operating in the background at all times for all treatments. And we monitored these trap contents from August through October. And then we did harvested fruit evaluations to see what post-harvest damage would look like. This is a sample replicate. So it was a 300-meter stretch of orchard border. Just to give you an idea, this is a very tiny fraction of the orchard area in this. So it's very large orchards. And we monitored the impact of these border treatments on Bmsb intrusion into the orchard interiors using these sticky traps centered in the center of these treatments. So we found that much as in 2018, the poncho traps did catch about 3 times as many stink bugs as did the ghost traps. This is basically exactly the same 3 times factor as we found in 2018, but this time because of replication, we found it was significant. So that was really encouraging. However, when we looked at the impact of the traps on intrusion into the orchard interior, we found there really wasn't a significant difference. It was numerically lower for the poncho traps, but not significantly so. And then when that same exact trend was seen in the damage evaluations. It is interesting to note that the same numerical relationship existed where the poncho traps had numerically lower but statistically insignificant amounts of damage. So due to a number of factors, and including anecdotes by the grower that maybe the stink bugs were flying in from the very tall border vegetation consisting of 150-foot tall Douglas fir trees and all of that, and they're gliding over into the orchard interior and bypassing our border traps. That was kind of an interesting thing that merits more investigation in the future. We were suspecting that 100 meters for a trapping treatment was not enough, and that there was overlap in Bmsb migration that was kind of confusing treatment effect. So we decided in 2020 to adopt a modified approach in which we hung the insecticide netting directly on the trees. And this was also in response to the Letsky lab findings that coupling the pheromone with the host plant volatiles was a lot better for retaining the stink bugs. And we also increased the border coverage to more completely encircle the blocks. And then we bumped our sticky traps for monitoring Bmsb populations in the interior. We bumped it 40 meters in instead of 15, just to make sure that we weren't drawing in any stink bugs directly from the border vegetation. And again, it was the grower standard operating in all blocks, but we added the insecticide netting as a supplement in that treatment. And then we did damage assessments again. So this is what a sample replicate looked like. And we use 50-meter spacing. That seems to be what people like to do, and worked for us. And then there was an unsampled buffer zone between these treatments to make sure that there wasn't any overlap. So we did find significantly fewer stink bugs in the block sections that were treated with insecticide netting. It was not significantly different, but in terms of damage, the damage was significantly lower in the insecticide netting supplement treatments. Now, you'll notice that it was still 10 to 12% damage. So clearly there's something else that needs to be done to modify this or to tweak it to make it more effective, because 12% damage is not great in this context, really, or in any context. But so I guess future research will have to work on refining that and maybe incorporating some of the threshold spraying that the Letsky lab has worked on, among others. Now, it's kind of an extra little pilot study in 2020. We worked on incorporating a light with the poncho trap to see whether we could increase any captures. We had some technical difficulties with battery capacity and all of that. So we didn't really get it online until August. And we caught numerically, we caught more in the trap supplemented by lights, but it really wasn't that significant. And we think that's because in the climate where these traps are deployed, late season, the nighttime temperatures were dropping enough that Bmsb was really not flying. And this is kind of the same thing that was been proposed by others who've done light trap stuff. So that's going to need some refinements and hopefully some early season deployments to see if there's any difference with that. All right, so that's all that I have for my work, but I'm going to summarize what colleagues have done elsewhere in the country. So the Croft-Check lab has been working on monitoring Bmsb abundance and trap catchers using these ghost traps. They're finding kind of numbers dropped a bit from 2017, which seems like a fairly large outbreak year, and you can see the distributions of trap captures. There seems to be a peak in mid-September, centered around mid-September, which we've all seen before. But yeah, what really struck me about this was catching 450 stink bugs per trap per week. Those are almost unfathomably large numbers for us in the Pacific Northwest, but glad to see them being removed from circulation. They're also working on comparing net age effects. So these long-lasting insecticide netting traps the material is somewhat expensive, but they are purportedly able to last for multiple years. And so the crop check lab was testing this, and they found that yes, indeed, a 2-year-old net is still basically just as effective as a new net, and it drops off a little bit by the 3-year mark. But in any case, it's still improved over the pyramid traps or the white nets. So it seems that black coloration is also an important component of their efficacy. We did another study with net size, seeing what effect that had on trap catchers, and the full-size nets consistently did better than the half-size nets. So wider panels again seem to be more effective. And this was true even among white nets, but again, the black coloration seems to be superior for this. All right, so moving on to North Carolina with the Wagenbach Lab. This is kind of a quick summary. It seems that, again, the attract and kill treatments are best used as a supplement to insecticidal control rather than as a standalone fix-all. And they're probably especially helpful for highly susceptible cultivars and also areas where you can't spray quite as freely, such as you-pick operations, where you have to be more sensitive about spray timing. So the Wagenbach Lab research is looking at optimizing lure dose and also distance between these attract and kill stations. So lure dose found that there's not a huge difference in the orchard interior, but more lures do seem to increase the efficacy and decrease the damage, at least in the orchard borders themselves, but that difference seems to disappear the farther into the orchard interior you go. And that seems to also agree with our own insecticide netting traps, where the treatment difference didn't really seem to manifest itself in the orchard interiors. And there might be a similar factor at work here. All right, the Goot Lab via John Pope. They've been working on evaluating fruit injury counts and trapping Bmsb also with a smaller netting trap with the delta meat, excuse me. So this is the shepherd's crook trap design with the netting, the barrier cloth underneath. And this is kind of just a raw evaluation of efficacy for reducing damage. And again, we find the treatment effect of attract and kill. It did drop damage, but we're also seeing about the 10% damage of the fruits. And also noting that there's difficulty in deploying these insecticide traps on the borders. I imagine they're having much the same problems that we're having in Washington with narrow orchard borders, and also potentially tractors and equipment knocking things over. And feel free to chime in afterwards for any of these colleagues if there's anything I'm missing. And then lastly, the Lesky Lab is working on transitioning away from spraying baited border trees towards using these insecticide netting attract and kill stations. And specifically, she's looking at where should the nets be positioned relative to the orchard trees for maximum impact. And so there's the outside the orchard approach, in which the pheromone and the host plant cues are totally decoupled. And then there's the hung directly on the tree approach, which should be maximally effective with grower standard, and then kind of an intermediate approach where it's in the orchard but not touching the tree. Also, seems that monitoring is a key part of all this, because even if you do have these traps set up, you do need to be monitoring populations in the orchard interior. She's been using a threshold of 4 adults per trap to trigger the spraying regimen. And again, it really doesn't matter what the insecticide trap or the insecticide netting trap regimen you have, you need to be monitoring the population in the orchard interior. So found that the outside the orchard attract and kill station was not really effective. It was actually higher than in the sprayed orchards, the fruit damage. And there were more sprays triggered additionally.
2 minutes, Jim.
Yeah. What?
2 minutes.
Okay. And then for hanging the netting directly on the trees, that did in fact have the best results. So hanging these insecticide netting attract and kill stations directly on the trees seems to yield the best results. And that's a substantial improvement, it seems, over the sprayed control. And then the intermediate approach had kind of intermediate results where it was more or less a wash with some slight improvements in the near tree attract and kill stations. And the reason for the improved performance of the directly on the tree attract and kill station treatments is again the association of the pheromone with the host plant stimuli, which seems to be the main takeaway of this. And then going forward, Lesky Lab wants to refine the threshold for doing border sprays rather than the entire orchard sprays. And then again, work on using border sprays instead of just the complete orchard spray down when that threshold is exceeded. And then also see how Trisolicus japonicus works into all of this, and to see whether the reduced spray regimes might facilitate japonicus success more so than these spray everything down approaches. There's the Lesky Lab pre and post COVID, and yeah, and with that, questions.
Thank you, Jim.
And again, any of the colleagues whose research I presented potentially clumsily, feel free to chime in and let me know if I missed anything.
There is one comment from Jan Menely who says, sorry, but just recently the LLIN we provided has been discontinued in the US. Tried my best to get it commercialized. There may be an alternative. Contact me for more info.
Thank you, Jan. I was just going to ask you about that. We're going to move on now to Tracy Lesky once again, and she's going to talk a little bit about area-wide management of brown marmorated stink bug with a project she's initiated in the Mid-Atlantic region. So, Tracy,
Thanks,
it's all yours.
Can you see it, Jim?
Yep.
Okay, great. So yeah, as Jim said, I'm going to talk a little bit about the Mid-Atlantic Area-Wide Project. This is one that's funded by the USDA ARS Area-Wide Program. And you can see that we have collaborators at ARS, Rutgers, Penn State, Maryland, WVU, and Virginia Tech. So these trials were conducted sort of in the heart of the original Bmsb outbreak in the Mid-Atlantic. And the area-wide objectives that we had were to implement biorational management of Bmsb and key specialty and row crops. So this was sort of the in-crop kind of management tactics, advanced strategies for enhanced biological control. And this would be toward the next objective, which is assessing impacts of biointensive management on Bmsb populations at a landscape scale. We really wanted to reduce these. And then we also were working to promote adoption and implementation of some of these biointensive tactics. But the bottom line was that we wanted to use combined landscape level approaches to suppress Bmsb populations and reduce ecological and environmental impacts. So as everybody who's part of this area-wide program can attest, it took us a long time to come up with a design that we all agreed upon. But in the end, we ended up with what we referred to as our management site and our companion site. And these would have similar landscape features and percents of those landscape features, as you'll see in them. This is a 5-year project. The first 2 years, we really just collected baseline data on both Bmsb populations as well as natural enemies. And in the last period of the project, we implemented biorational or biointensive management. So these are our 4 area-wide locations. Ann Nielsen had a location in Glassboro, New Jersey. Greg Krawczyk near Lancaster, PA. Our locations were in Martinsburg, West Virginia, close by, and Chrisburg in Winchester, Virginia. And so the way these sites were laid out, they were 1 kilometer by 1 kilometer. And we also had these companion and management or area-wide sites, these 1 kilometer square sites, about 1 kilometer apart. And the reason for that is if we went too far, we might not capture the same kinds of effects. This is where this is where a lot of discussion came into play. But we settled on this. And so with the magic and help of Young Loch Park, we were able to map these 4 different landscape elements, sort of structure, housing, woodlot or windbreaks, fruit trees, and vegetable and field crops were our 4 major landscape features. And these were mapped and matched accordingly, and you'll see what I mean. We also divided these sites into 9 quadrants, and we used what is referred to as a stratified systematic sampling approach, where we had 3 traps per quadrant, and they were placed at the border between 2 of these landscape elements. So between fruit trees and field crops, for example. And these were at least 50 meters apart, and they were sampled from May to October, and we used clear sticky panels. So I'm going to take you through some of the baseline data generated in 2017 and 18, and then I'll talk a little bit about what we did in 19 and 20. So these are just the West Virginia sites, but it'll give you a sense. Everybody has similar kinds of things where we have our management site and our companion site. And what we would do and what Young Loch would do would sort of move that square around until we could kind of match those landscape elements such that there was no statistical difference between them, so that we had sort of equivalent sites. From there, he would also help us map out where to put these traps. And again, we tried to break them down such that we had equal numbers, not just in each quadrant, but also at these interfaces as much as we could. So this was our management site, and this was our companion site, and the number of traps in those interfaces. Here are the captures in our baseline years, 17 and 18, the mean number of Bmsb per trap in the management and companion sites. And you can see they look remarkably similar. So I think we did a good job. Looking at the seasonal patterns, similarly, pretty close. So that was good. And then also just looking at the numbers in our different landscape elements, sort of field crop, tree fruit, woods, that kind of thing. So again, that was the baseline data. From all of those trapping then, Young Loch conducted spatial analysis, typical SADI analysis, where you're looking for patches, a region of relatively large counts close to one another, and gaps, also sort of known as cold spots and hot spots, where you don't have a lot of captures close to one another. And so from West Virginia in 2017 and 18, here is the companion sites. You can see the hot spots, which are in black, and the cold spots, which are in blue. And the hot spots are, you can see they're near some of our woodlots in particular, versus some of our sprayed orchards where there were some cold spots. The management site, you can see again, pretty similar kinds of areas where we see our hot spots and cold spots. So that was the baseline data. In 2019 and 2020, we continued to monitor these sites both for, and I don't have time to present the natural enemy data, but again, the Bmsb as well. But we also were working to promote adoption of these biorational IPM tactics that we were developing on our own, things like the thresholds, attract and kill, phenological models that Ann was working on, as well as border sprays. And just as Jim had talked about previously, we had attract and kill that growers could take on, thresholds or border sprays, as Ann has pioneered. So that was kind of the in-crop tactics that we were trying to get them to consider using. But we also were doing TJ releases, Trisulcus japonicus releases. And based on Kim Homer's guidance and Don Weber, what we ended up doing was to put out 100 parasitized egg masses at 2 points in the season based on some of Nicole's work, where we saw sort of early June and late July, early August peaks of Trisulcus japonicus activity. And again, after much discussion, we agreed that 30 to 50% of the egg masses would be deployed along wood lines, windbreaks, and fragmented patches in the quadrants where we had the hot spots, whereas the remainder would be placed along similar habitats in our other quadrants. And then we would record egg masses in terms of the emergence, and we also monitored with sticky cards. So this is just to give you an idea. In our management location for West Virginia, those are where those hot spots are. And so each of these represents 10 egg masses. This one egg mass represents 10. So you can see that we deployed a lot in these quadrants where we had hot spots, but then we distributed others throughout the rest of the site. Now, I don't have more data. Younglock's working on it, but here's the thing I wanted to show you. So 18 was still our baseline data, and this is the number of Bmsb per trap and numbers of adults and nymphs season long, and our threshold of 4 adults, just to show you where we saw peaks in activity pre-TJ release. This is from our management side. This is post-TJ release. We actually have more Bmsb in these sites than we did in 2018. And it follows that we had 2 hot, dry summers in 2019 and 20. And so it really gets at this notion that we have to start thinking about abiotic conditions and their impacts on relative population densities and population dynamics. So in terms of next steps for this Mid-Atlantic area-wide project and other similar projects, in the Mid-Atlantic, we're hoping to continue to monitor at these sites and potentially look at longer-term trends of Bmsb and Trisulcus japonicus, but we may need further releases. We need to optimize our Trisulcus japonicus releases. We need to enhance the impacts of our native natural enemies, like Paula described, integrate crop-specific and landscape-level tactics to maximize and synergize our impacts against Bmsb. And the bottom line is we need to understand more about abiotic conditions like hot, dry summers and cold winters on Bmsb and TJ. And now it's time for some polling questions.
Okay. Next, we're going to go to a little bit different topic. We're going to go to the economic component, where Jay Harper is going to present us with the results of a survey that's been available for growers and other peoples for quite some time on the Stop Bmsb website. So, Jay, it's all
right. All right, thanks, Jim. Can you see my screen?
Yes, you can.
Yes, good. Well, good afternoon. I'm Jay Harper. I'm an ag economist at Penn State University, and I've been involved with the brown marmorated stink bug work since the beginning. So it's been quite a ride, I guess. We did a management survey that we put out beginning in June of 2018. And the idea here was we wanted to get I want to give you an update on that data, since I really haven't talked about this since the Columbus meeting back in 2019. And at that time, we had relatively few number of observations. We certainly have more data now, give you a little bit better feel for what kind of information we're getting. But the idea here was to assess the value of different kinds of sources of brown marmorated stink bug management information. So where it came from and how people might be using it, and also their potential use of the different kinds of tactics. We also wanted to estimate the economic value of biological control. And of course, this is a fairly complicated undertaking, especially when we're talking about a pest that attacks so many different kinds of crops over such a broad geographic area. The idea of gauging the value of biological control is really the hypothesis is that we'll be able to see if we have successful biological control that would lower the pest management costs, increase our yields, and improve the quality of the crop itself. So to do this, there's various techniques can be used by economists and so on. One of the big ones that's used is something called contingent valuation method. And so this is a way of getting at what is the value of something that's hypothetical in a lot of senses. And it's commonly used to value public goods, like how do you value a park or something like that? Or how does something that's an externality, something that's bad out there in the environment like pollution, how does that affect my quality of life? And then it also is used to just generate what we call existence values for endangered species or unique landmarks that we may never visit or never have interaction with, but still want to put a value on. So this is a well-accepted technique that's been used for many different things for a long time. And so for the brown marmorated stink bug, the survey is being used to determine the perceived value, the potential acceptance of biological control. And we use the example of Trissolcus japonicus as to explain the process to the survey respondents, but it could be used to evaluate other kinds of biological control as well. So to date, we've received about 295 survey responses. This is all online. So anybody can go into it. And so you get a lot of homeowners getting in there that don't necessarily shouldn't be in there. But out of that, depending on the question, and it wasn't required for the respondent to answer every question if they didn't want to. But we got somewhere between 110 to 190 usable responses, depending on the question. And that's certainly not as many as I'd hoped for initially, but it's enough for us to do some analysis and make some pretty good conclusions. So out of this data, about 50% of them were commercial growers, or how they define themselves as commercial growers. And they had a average of 29 and a half years of farming experience. So a very experienced group of growers. We also had a fair number of smaller part-time producers who had about 23.4 years of experience. And then we also had some crop consultants that answered the survey, and they averaged 12.6 years of experience. So we've got a fairly good representation of the different kinds of decision makers with brown marmorated stink bug. The survey responses to date, about 57% of them said they were solely conventional growers. 16% they said they were organic producers, and then 27% indicated that they grew crops both organically and conventionally. We have a good mix of annual value of sales, which kind of tracks that part-time small farmer and versus commercial farmer group. But this is pretty typical of a broad survey like this. You get a lot of smaller people, but we have everything up to from very small to quite large operations that responded to the survey. Now, the types of crops that are grown or managed, and certainly the respondents could select more than one crop that they're growing. So that's why these percentages don't add up to 100. But we had a good mix. We had some field crop growers, a lot of tree fruit producers, a good number of small fruit growers, good number of vegetable growers. And then we also had, with the Western Coast people coming on board, we started seeing some nut operations, but also nurseries, not really many grape growers, but again, a good mix of different kinds of crops represented by the survey results. So when did brown marmorated stink bug become an issue? And again, this represents a broad cross section of what's going on in the country. So we had growers certainly here on the East Coast that were affected very early. And then we've got growers on the West Coast that are just learning about the problem, maybe at an extension meeting or so on. It isn't a problem yet. So we've got a broad range of people with their experience with the brown marmorated stink bug, and I think that gives us some robustness to our data. So how concerned are growers about the brown marmorated stink bug now than when they first saw them? And there's some that are less concerned, but in general, I think what they're saying with their experience that they're more concerned. And this may represent the fact that we've got more West Coast growers participating in the project and so on. But certainly there's still a lot of concern out there. Some don't have a lot of experience with it yet, but again, we've got a range of people with their experience with the brown marmorated stink bug. So how has the Bmsb impacted the profitability on their operation? And the issue, you know, with a 15-minute presentation here, I really can't slice and dice this information a whole lot. I can't talk about every single crop type or type of grower or so on. So these just represent the answers for the entire group. But one thing that I will be doing, I'm going to be working with some ag economists and economists up on campus to do much more detailed analysis on this so we can get at some of the specific impacts to the different kinds of commodities, different types of growers, and how they would have responded to these kinds of questions. But in general, you can see the kinds of impact that it's had. There's still a large proportion that have had no impact, but we're seeing, 1 in 10 growers have seen what they consider a severe impact on brown from the Bmsb, and about 4 out of 10 have either had a moderate or slight impact because on their profitability because of brown marmorated stink bug. So there's some definitely going to be some growers seeing value to things like biological control. So where they feel they're getting their best management information on I don't know why I'm tongue-tied today. Bmsb, we'll say that. Where do they see they're getting the best management information? Well, it's gratifying to seeing that they're seeing us researchers and the local extension people being as very high value sources of information for that. Extension newsletters and websites are kind of more, maybe a tier below that, but still very valuable. One thing that's seeing here is that the Stop Bmsb website is not being used maybe as widely as it could be, but still being a valuable part of the mix of things. And you can see that information from other farmers and crop consultants isn't valued quite as highly as some of the extension or research type of information. So where do they think that they'll use some of these tactics? And we had a list of 7 different tactics here. So whether they're going to use improved monitoring techniques or track and kill, trap crops, repellents, netting and barriers, border sprays, or different things to promote natural enemies. And so you can see certainly that a lot of them are looking at using improved monitoring techniques, that they'll include those in their toolbox. And the other ones, attract and kill, trap crops, repellents, and netting and borders, I suspect these are very commodity specific. And certainly you're not going to be using netting and barriers much on fruit trees and so on, where you may use those very, to a large extent on things like small fruit or something like that. Certainly if you're an organic grower. But this does show that there's a lot of interest in these different kinds of technologies. And as we do kind of slice and dice this information, we'll have better idea about maybe where we could focus some of our educational efforts with different kinds of commodity groups for the kind of information they'd like to receive. So we did ask a question about biological control using Trisulcus japonicus. And, so we had a pretty dense paragraph for them to read explaining what it was and what was going on at the time and so on. And 88% of the growers said they would want to see it released in their area. So that's very encouraging. And a large portion of them, 86%, said they'd be willing to have it released on their own operation. So I think there's a lot of excitement about the Trisulcus japonicus. There was some a fairly large number of growers still had some concerns about how the Trisulcus japonicus or some other biological control agent may have an impact on other kinds of insects. And so that's, a lot of that's just better education and so on, but that's part of the barriers to adoption is the perception of how these kinds of things, you know, especially since we're talking about invasive species, they're concerned about more invasive species. So, and certainly there have been issues with that in the past. So what would be the willingness to pay for biological control? So we formed the question as to if you had a biocontrol with different kinds of levels of efficacy, how much would you be willing to pay for it? And we got about 120 growers answering this question. So this was, I was very gratified with this. And you can see as the efficacy goes up, the willingness to pay goes up. There were certainly, this is one area where slicing and dicing the information will give us some more information because, you know, the median values for what they'd be willing to pay are quite a bit less than the averages. So what that's telling me is that there's some growers that are valuing this very highly, and they may have some very, very valuable crops that they're trying to protect. So just taking an average of all growers doesn't really tell us what we want to know. But we'll be doing a lot of analysis on this in the next couple months. I only downloaded this.
2 minutes, Jay.
Yes, sir.
2 minutes.
What's that? 2 minutes. Okay, I'm good then. I only downloaded this data at the end of January, and there were still people that had responded to the survey in January. So, you know, this, I really haven't had a chance to dive too deeply into some of these different ways of looking at the data. But again, what they're also saying is that if in order for them to believe that they could eliminate insecticide applications, they'd need at least an average of 84% efficacy in order to do that. So fairly high efficacy from a biocontrol. So they also asked them who should pay for this, and there was everybody from, oh, I'd be glad to have it, you know, and I'd be glad to pay for it. And the other ones are really pissed off because the government didn't do more and all that kind of stuff. But anyway, the main group was saying that they thought that agricultural producers and the government should do some kind of cost share for the program. There were a lot of them that said they'd be willing to do it on their own, at their own cost. Not so much wanting to approach it as a commodity kind of program where they would be paying a checkoff or something like that. There was still a group that would say, I don't want to use it at all. I'd rather use other types of tactics. And then 8% said the government should pay all of the costs. So again, future evaluations of the survey data, we'll be using various econometric and regression techniques to assess the impact of the grower attributes. So different types of growers, different crops, different scales of operation, and so on. We're going to have to use some techniques called multinomial logit models because we're looking at ordinal scales, Likert type scales for adoption of different things. And then we're going to be estimating the biological willingness to pay, which is really a function of the efficacy level, the crop, the types of growers, grower locations, how much experience they've had with brown marmorated stink bug, their attitude towards the use of other management techniques, tactics, and then their attitude to the use of biocontrols, and then who should pay for them. So I want to thank you for this opportunity. I do not have any follow-up questions as part of my presentation.
Thank you, Jay. It's interesting. Now we're going to come down to the last presentation of the accomplishment section of the project. And that's going to be by Deb Grantham, who's going to give us an update on the outreach activities. For those of you who may not know, the Northeast IPM Center plays an important part of this in terms of kind of being essential location for all of our output session or output information and leading that effort. So.
Thanks, Jim. I'll apologize in advance. All of my animals and family all woke up from their siestas, and so there's noise in the background. So I am talking about the outputs and outreach part of the program, although you've heard about a lot of the outreach in the past presentations. Some of this is just the bean counting, which we have to do. And so I'll show you these beans, kind of 4 major categories on this slide: research, publications, extension publications, which are the outreach, conference presentations, which often are the research results, and extension publications. So very productive project over the 4 years. This is a bar graph that makes it a little easier to look at, bars instead of beans. So you can see that 2017, 18, and 19 were quite productive. 2020, we all got nailed with stay-at-home restrictions. And 21, we're still early on. It does include some numbers from that. That high number is 100 individual publications or presentations. There's been quite a few extension presentations across the country. And because that was just a bunch of numbers, I thought I'd at least give you a few links to a very few of all the links that there could be for getting at people's extension publications that can assist with management. So they're at the researchers' websites in large part, and you can find those researchers on the Stop Bmsb website as well. We'll see more about that, but here are a few, and I think you can go from these to other places as well. One of the things that we need to count, and I think that one of the really important outputs of the program of the project, we're mentoring young scientists, grad students, and postdoc students. So 29 of each. We all know Emily Ogburn, who left and came back, fortunately for all of us, but these are good numbers, and these are the people who carry on the research and the extension in the future. There's also quite a bit of leveraged funding from the project. So the original USDA funding was a little over 9 million. And then various collaborators and co-PIs on the project garnered other funds. I suspect that a lot of this, a little over 4 million of leverage funding was from USDA, but I'm not sure. And the individual researchers would have to speak to that. But the amount has been quite substantial. And this, again, it doesn't count 2021, and we have a lot of RFAs out waiting for proposals right now. So I think that there will be additional funding leveraged from this project. StopBmsb.org has been mentioned a few times. It's the official website of the project. The Northeastern IPM Center hosts it, and Kevin Judd is the web manager for this website, and he does a fantastic job. Over the course of this 4-year project, there have been a little over 366,000 unique users of the site, which is over 80,000 visits a year. And there are about 130 pages of content, so there's a lot to look at there. Some of the things I thought that people might go to pretty quickly, especially based on the presentations yesterday and today, would be just the basics of stink bug biology and behavior, management approaches. There's a whole list of scientific publications, and I think that's pretty extensive, maybe not totally complete, of what's been published out of this project efforts. And then biological control is another, gets its own separate pages. So this is really worth looking for and looking into. There's a lot of your questions can be answered here. We also, just the center itself, one of the things that we did is outreach, where Nancy Cusmano did this. You've been hearing her read the questions in the Q&A, which she assembled and sent out these BMSB ID kits with almost 2,000 of them over the years, 25 states and Puerto Rico, 4 Canadian provinces, and some overseas countries. I think one was to a shipping company and they ordered quite a few. So it includes an adult insect in the hand sanitizer bottle and a bunch of written information in a bag that holds it all together. We haven't, I think Nancy said that the last time that we sent any out was September. I'm not sure if we have any supplies left either, because I think people ordered them so they could get the hand sanitizer there at the end. We have a newsletter published by the Northeastern IPM Center. This is outside of the project. It's funded by USDA, but not funded by this project. But we do put articles about BMSB in the Insights newsletter. The June 2019 issue was really focused on BMSB, and we've had about 20 articles and announcements on BMSB since 2016. We can do more of that. We can focus another issue on BMSB this year if that's the wish of the group. But certainly we can always, you're welcome to submit articles and announcements to us for publication. We put it out about 4 times a year, and that's Mike Webb's responsibility. We did one webinar, again, that through our own separate funding in 2017 on BMSB and IPM techniques, and I think it might be time to do another one, but you could find the recording of this one at this link on our own Northeastern IPM website. We also did a stakeholder survey through this for this project last winter that there were a few questions that related to Jay Harper's survey, but more we were looking at input on the project itself. David Lane was the lead on that from the Northeastern IPM Center. Went to, we got about 105, we sent it to the COPIs, Research Extension and private IPM practitioners, so a little bit further than the collaborators on the project. We got about 105 responses, 40% were extension, 35% were COPIs, 10% consultants, 4% were from the stakeholder advisory panel, and then 12% other. And it's too much to summarize in one slide, but I thought there were 2 big points that I got out of it for this presentation. And one is that in general, the COPIs on this project tend to estimate the levels of adoption to be higher than non-COPIs estimate levels of IPM adoption. It was a convoluted way of saying that. I hope it made sense. And then the second point that I got out of it was that the high cost of implementation is not a top barrier. The data actually suggests that some of it is just awareness and thinking that the research is incomplete. And so more improved research or more extension about that research and more extension in general about IPM for BMSB would lead to greater IPM adoption. And then I want to just go back to stopbmsb.org for my, I think this is my last slide, because there is a contact page, and that's, I think, useful for people. If you have questions about what they've published, what their extension publications are, how to get to them, or other types of questions, there is a contact page on Stop BMSB that I'm showing here where you go to About Us and Contact Us. And so that can be a useful way to reach the collaborators on the project. So there you go. And there's one question here about Stop BMSB.
So I encourage you, if there's any questions anybody had for the last group of speakers, please ask them now. We spent a lot of time on pheromones, and it's going to be interesting to, most of us that have gotten into this attract and kill are using insecticide impregnated netting. And you saw Jan's comment before, how he said that it's not going to be available going forward. So hopefully we can work with him in some manner and see what we can come up with.
Hey, Jim.
Yes.
I don't know if Jan can chime in either written or, but is it Vestergaard that's just not making it available? So they just don't want to put it on the US market. There's nothing we can do to change their mind. I always consider no the first step in any negotiation. So I just want to ask if there's any possibility.
Hopefully we can hear back from him shortly.
Or perhaps the switch to the BASF netting, which I don't know. I think it's a conversation it's going to need to be had pretty soon here, because there's a lot of experiments, at least, not to mention potential of growers using this technique. So, I mean, we got to.
Exactly.
We need to address this.
Yeah.
Looks like Jan dropped off the call. Maybe he's having tech trouble, so I don't see him on the list anymore.
Oh no, I see him. He's there. I
There he
see
is.
Jan.
This is Anne. Even if we can't use it, if it's not going to be available commercially right now, if we could use it experimentally, then maybe we could gather enough information with multiple pests that would help put with a petition for a label or something like that.
I just made Jan able to talk, but it's still muted, so Jan would need to unmute in order to talk.
Gotcha.
There we
Can you
go.
hear me?
Yes.
Yeah, there.
Okay. Yeah, I was on, sorry, I just had a phone call from Tennessee State on a project. Okay. So the deal is that Vestergaard has pulled all their operation from the US. They were mostly a mosquito control company. They had one person here in the US that was doing agriculture and mosquito control, and that person was asked to resign, or they fired her.
Oh.
So they have taken, basically they quit the US under great protest, and even though they've seen all the research data, they didn't care. So that's an internal thing with Vestergaard, and I couldn't do anything about it, even though I've been on this project with LLIN for 8-9 years now. So the alternative is that I've been in discussion with BASF. They have a registered net, cypermethrin net, that's registered for stored grain, or actually the tobacco beetle. And they are willing to provide that to the research community if you sign a material transfer agreement. And I've been through this before with them, like 5 or 6 years ago. And what that means is that all data generated is the property of BASF, and you cannot publish it unless they permit that. The other hang up is that the net does not have UV protection. So it's unknown how long it would actually last in a field situation. And that's basically it. BASF, I have no more Vestergaard net. It was quickly taken up by Penn State and University of Georgia. I do have some yellow net, if anyone cares, because we were all into, we'd have black net and we'd have yellow net and all sorts of opportunities. But I've been marching down this primrose path for the past 5 or 6 years with Vestergaard. So,
Dan, is the BASF net the Stura net? Or does it have a different brand
yeah,
name?
the store net, yeah.
The store net?
Yeah, store net, but no, it is not. That's the one that is used in Europe for the Ips beetles and attract and kill. But the store net is not the same formulation as what is in the US. The one in the US is the Carafend net. The store net in Europe does have UV protection, but they have not registered that here. And they're telling me to add that it would be costly, difficult to add UV protection to the current net here in the US. It probably can be done, but it will take time. So right now, the only thing available would be that non-UV net from BASF under this material transfer agreement, which maybe some of the universities will approve it, or you as a researcher can approve it. I know that it causes consternation because you can't publish. It becomes their property unless they would permit that.
So that is the BASF netting, is that put out by their agricultural division or a different division?
That's under their ag division, yeah. Because it is registered. See, the beauty of it is it does have a registration in the US for the tobacco beetle. And it's used, actually it's registered in 1 or 2 states where they cover tobacco bins in a warehouse to keep out and kill pests that try to get in there and eat the tobacco. But they are interested. They will provide net, but there is the material transfer agreement deal and the UV deal. So that's kind of where it is.
Well,
yeah,
we've evaluated other things under material transfer agreements before.
Okay, well then that's good for NC State. Yeah. I think it just takes a long time to get it approved. Maybe it depends on your university. Would take because it has to go through the legal department, and then you probably can't publish it until they approve it. So that's kind of the choice right now.
Yeah, Michigan State's legal department won't accept it.
Okay. I think Penn State was the same way.
I think Virginia Tech ran into problems a few years ago. We tried to get that netting too. But Jan, I'd like to add that there is a really good published study. It was done in Europe. I forget where, by whom, but
yeah, I think it was Italian. Yeah, I have it. I've read it. Yeah, I know.
I mean, it did show that the BASF netting is effective. I mean, you're going to get a good product if we can get it.
Yeah, I think though the one that was published wasn't it from Italy? I'm pretty sure that had the UV protectant in it. That only makes sense because it's the store net, the one that is commercial in certain areas in Europe for the Ips beetle. But no UV here. So that's a whole nother formulation that has to be approved by EPA. It would seem to be minor. I think it probably is minor, but still then that they would have to add it in the production process. It would have to go through the lengthy EPA review, but it's possible. Definitely possible. And the net here, the Carafend is white, not black. So that's a difference too. May not make any difference if you're doing a attract and kill.
Well, I think people involved in this, who this is an issue for, we probably need to have a separate meeting to discuss how we might want to go forward with this.
Okay,
So,
Thanks, Jan, for the update.
yeah.
really useful.
But again, there's been so many, the research community has done so much work and the results have been so positive that it's kind of unbelievable that Vestergaard would pull out.
So I suspect probably that the potential market here is a drop in the bucket compared to what maybe mosquito.
Could very, yeah, and it's mosquito. It's a mosquito company. I mean, the net is for that purpose sold in Africa and other places where malaria and all those, you know, all the mosquito problems are. So yeah, that's what they do. That's what they're comfortable with in the agricultural area, even though they were selling some into Norway for use around crops. For one of the flies, it was the carrot flies, or was it another? I can't remember. But anyway, yeah, they were selling some there. That was the yellow net. And I do have the yellow net still. But everything else has been taken away by two research groups here in the US. Spotted lanternfly, it's deadly on spotted lanternfly, as you know.
Okay, we are at the point where we're scheduled to take a short break before we come back for the interactive component of this. So I would say everybody plan on being back here at 3 o'clock, which according to my time is about 9 minutes from now. Thank you. Hello, everyone. I just got back. It's about 3 o'clock here. Let's see. It's a little bit different than an in-person. Coming back from a break is a lot more difficult virtually than in person. So you just never know who's here. Okay, at this point in time, we are going to move to the interactive stakeholder input session, which Nick Wyman is going to be running. So Nick, I'm just going to turn this over to you for however long it takes.
Thanks, Jim. Are you guys seeing my screen?
Yep, that looks good.
That looks good, yep. Okay, good afternoon, everybody. Thanks for hanging in until the end of the meeting. My name is Nick Wyman. I work at Oregon State University. I'm an orchard specialist. And I'm going to sort of be moderating this next section, which is really about, you know, where do we want to go from here? So I believe we just basically completed the last stakeholder advisory meeting from the current project. And so this next section is really about, you know, what's needed in the future for Bmsb research. And we're hoping to get some inputs from stakeholders, as we have been all along, but I think there's more opportunity in this session to be more interactive. I'm going to have some partners through the section. So Dave Crowder from WSU, Kim Holmer, and Tracy Lesky from USDA ARS. I know there's crazy weather going on around the country, but this is what happened to us this weekend. This is a result of an ice storm on some hazelnut orchards. So I didn't want to miss an opportunity to share this disaster that we're living through right now. But the amazing part is that toppled hazelnut trees can actually be righted and will continue to grow. So I learned a new trick this week. So I wanted to start out today talking a little bit about the history of the Scri projects that have been funded for Bmsb work. So it begins in 2011 with Tracy. And the first project sort of followed a outbreak year of Bmsb in the Mid-Atlantic region, where there were some really severe impacts to apples were huge, but also some other orchard crops and other specialty crops as well. So Tracy mentioned in one of her talks earlier that, you know, there was really very little known at that time about how to address the problem that was affecting so many growers economically, and there just was very little information about the pest and its management. So that first project was really sort of an emergency response to the outbreak conditions. And that was a very successful project. And in 2014, sort of toward the tail end of that initial SCRI, there was a lot more evidence that Bmsb was becoming a problem out west as well. So we had a separate SCRI planning grant where we sort of tried to address Western Bmsb issues, and we had stakeholder sessions around the Western US and try to incorporate stakeholder inputs into that project. And a lot of that ended up getting incorporated into the 2016 project, which we're now at the end of with Jim Wagenbach as the lead. So going forward, we need to act now to try to keep the continuation of the funding going. So throughout this meeting, we've been hearing about all the great research that's been done, all the great extension, and so many products, really overwhelming. Just quickly recap, you know, a lot was learned in that sort of initial response on short-term mitigation strategies for the Bmsb. Tons was learned about insecticides in those first years, as well as monitoring tools and applications, phenology of Bmsb in crops around the country, damage and risk on numerous specialty crops, biological control, you know, really focused initially on the impact of native species and then moving later to more focus on Drosselchus japonicus, entomopathogens, landscape risk factors, and it just goes on and on. So really a ton has been accomplished through these projects. But there's a strong case to be made that we have a lot more to do. So one aspect of this is that Bmsb is still emerging in some regions of the US. So particularly the Western states, the Pacific Northwest and the Southeast region. And you could probably tack some Great Lakes in there as well. Another thing that's really apparent is there's too much reliance on broad spectrum insecticides. And where I'm at, it's prophylactic. So we have growers that are spraying regular pyrethroids prophylactically for Bmsb because they are so nervous about the pest. And we had really huge impacts in the 2019 season. And so in 2020, they were taking no risks. So to me, that really indicates that there's not enough information out there to support them moving away from this reliance on the insecticides. And as Tom mentioned, you know, things that work really well for Bmsb can be pretty hard on IPM. So these are pyrethroids essentially and neonics. We also have a lot of questions about the biocontrol. So when we first found out about adventive populations of Drosselchus japonicus, I think a lot of people thought this is going to solve the problem, but it seems to be a pretty more complicated, nuanced picture than we may have anticipated. And as we've seen throughout today and yesterday, there needs to be more research on some of these insecticide alternative tactics. And these include trap thresholds for more crops, perimeter management strategies, track and kill work, and further work with insecticides as well, incorporating them into IPM programs. So, and that same goes for all these tactics. I think a big need really is to integrate Bmsb management into established IPM frameworks, or else we're going to lose a lot. And by moving to pyrethroid sprays for Bmsb. And then to support kind of these transitions, I think there's needs to be more extension resources to improve adoption of these alternative tactics by growers. So we started out really not knowing much about what crops were going to be highly affected by Bmsb, and there's been a lot of studies on a wide range of specialty crops to look at damage and potential impacts. But you know, many years on from the initial outbreak, let's see, at least 11 years on, I think there's kind of a consensus now on crops that are most consistently impacted by this pest. And this is just a graphic that I got from the Stop Bmsb page that we worked on as a team to sort of highlight high risk crops. And you can see that we really are convinced that tree crops are going to be consistently affected by Bmsb. So we know Bmsb is an arboreal pest. It's a tree loving species. And so tree fruits and tree nuts, we think, are very high risk specialty crops. Additionally, some vegetables are consistently affected, and those could probably be narrowed to peppers, tomatoes, and sweet corn being, you know, most important. So we feel that in the future, the work can be somewhat narrowed down and focused to these high priority specialty crops where we anticipate there are going to be consistent impacts of this pest. So just to kind of run through some of the objectives that we're thinking about for future work. The first one, which Dave Crowder is going to talk about in a minute, is development of a national online decision support platform to provide timely and effective IPM decision making that's location based. And I'll let Dave get into more details on that. On the second objective, we're talking about refining and customizing some of the pest management tactics that have been discussed today, such as perimeter sprays, attract and kill, trap thresholds, and biocontrol. A big emphasis on biocontrol still, because we know that's going to be a key management strategy for this pest that is landscape based. A third objective is to integrate an area-wide approach into the SCRI project, and really building on kind of what Tracy's been doing in the Mid-Atlantic region. And this has many advantages because I think growers get to participate in implementation, and this also will involve the researchers, the extension people, the growers, the consultants, and other industry stakeholders. And will really give us an opportunity to refine some of the tactics, but also do some demonstration. And then finally, we have a more extension-oriented objective, which is I'm going to talk about in more detail later, but basically we have a multi-tiered strategy to improve extension outreach, to support our specialty crop industries to have better adoption of some of the tactics that we've been talking about. So I'm going to pause here and I'm going to hand it off to Dave to talk a little bit about the first objective.
All right. Okay, can you all see this now? Can you hear me okay?
Yes.
All right, I'm gonna run through this quick. Ann Nielsen and I prepared this, and we're gonna try to keep it to 5 minutes. No, we have about 10 slides. So as Nick mentioned, I think this team is a great example. It's been one of the best teams I've ever worked with that's combined research and extension. And yet it still seems like there's a ways we could go, as Nick mentioned, to develop a more coordinated platform to deliver outreach information on BMSB. And so if you're not familiar with what a decision support system is, I'll show you this in a second, but why do we as scientists develop such systems? There's several reasons. One is that there's a lot of people that want our information, producers, consultants, or other stakeholders. And there's not that many scientists. So we have to find ways to get information out to people in bulk. And internet and cell coverage has really changed how farmers receive and process information. You know, a need to go away from extension bulletins and more towards, you know, real information that's in real time in the field to provide these advanced warnings for pest management. So over the next few slides, I'm just going to show what some features of a decision support system might be as kind of a menu, if you will, of what we might look to develop moving forward in a BMSB project. And then we're very interested in getting feedback on that. So I'm the head of decision support systems now at WSU. So I'll show us some of the features that we have, and then we can think about how these are applicable to BMSB. So within a decision support system, you can get site-specific weather data. This is our site where you could click anywhere in Washington and either get data from these weather stations that are run by WSU, or you can click anywhere on the map and have something called virtual stations that are based on gridded weather data. And this can pull in data at a site-specific level that then can be used as an input for a phenology model, for example. And I think Anne will talk about that in just a second. So we have the ability in a decision support system to start moving towards site-specific management. And part of that is dependent on knowing how the weather changes from year to year. So we already have a platform to do that. Within a decision support system, as you know, we can build spatial tools to aid in assessment of BMSB. If we continue our monitoring efforts, we can display those monitoring efforts in real time, help growers get a sense of when insects are moving in and out of their fields, or when particular areas in the landscape need to be managed or don't need to be worried about at the moment. So Anne, this is your slide. I think Anne was going to talk a bit about phenology models here quickly. Are you on, Anne?
I am. So what Dave is talking about is similar to what we use on the East Coast, which is the NUA system. This is a kind of a weather station based degree day model with you know, management suggestions based off of phenology of the insect pest. So it's a little bit, you can enter in your biofix states, et cetera, but it's not based on real-time trapping networks or it's not gridded like Dave has talked about. So there's a little bit more, it's a little less, it's really good in terms of timing, but the DAS system, from what I understand so far, has some additional features. But so it's kind of a benefit of that. Go ahead. So just to kind of put into context what I was talking about yesterday with the phenology models, these are our outputs for the egg, nymph, and adult stages from Bridgeton, New Jersey, and Wenatchee, Washington. And this is the correct data from Wenatchee, so this is the corrected one. And I just wanted to put this out there because it shows how much overlap of different life stages that we have. And if you go to the next slide, Dave, this just is kind of blown up. You can see we have our adult stages in black, and those, you know, start off really high, start off really low each year, and then they increase throughout the season. We obviously have adults, and then we have our egg stages, and we generally see two big peaks of the eggs, but you know, it is still pretty contiguous. And then we have nymphs that are occurring right after that. But the adults are generally constantly present. So if we're trying to use the phenology model to time against specific life stages, that does have to be very specific. And it's going to be a very narrow window, just like we're talking about for what, like we're familiar with codling moth or oriental fruit moth or plum curculio or any of the other insects that we manage based off of degree days. Next slide. So the phenology model that we have so far, we know that we can predict population peaks for the adults. We can also predict peak oviposition. And this is an output from a database that we were working with Penn State on, their graphical user interface, or their GUI. And Shelby Fleischer was really trying to get this off the ground. Unfortunately, we had some issues with it. And so it's not really an option going forward, but this allowed us to enter in kind of using the national NOAA network of weather stations to enter in 30-year averages and get predictions on what will happen that year for each of our life stages using the model. So you can see here, this is the output for eggs, and then you see first 2 peaks, first generation eggs and second generation eggs. And then first generation eggs, second generation eggs, and then the same as for the adults. We know through other research that our phenology models can predict dispersal into the peaches at around 100 degree days, that's base Celsius. So we can use these types of phenology models when we integrate them with something like a DAS system to predict oviposition events that could time timing of insectary plant bloom, or timing of augmentative parasitoid releases for either Anastatis or for Trissolcus, so that we can really optimize our biological control systems. If we're trying to time targeting those nymph stages, which is going to be a very smaller window using an IGR or some other software chemistry, we can also use the models for that. When we look at this dispersal into apples, which is, obviously a major commodity concern for stink bug, that dispersal occurs later. I mean, we do get populations earlier, but the big peak happens primarily around the beginning of the F1 adult peak. So, we can combine a lot of these tactics, such as, trapping landscape features and a DAS system to predict when these peaks are going to be. I think that's it, right, Dave?
Yeah, and just to kind of follow up, this is what the system looks like at WSU, where this is codling moth. If you log on at any time, it's running a phenology model. It'll say something like, this is the percentage of eggs have hatched. And this is what really makes a decision support system different from a calculator. We can show growers a phenology model, but where we want to get to is, take Anne's model, our spatial density mapping kind of stuff that Tracy might be working on, and take all that and turn it into a management recommendation. That's where we want to get to, so that we're making life easy on people managing Bmsb. This is an example of a DAS system for codling moth. And this is a typical example of a grower in Washington that came to us and said they were getting bad codling moth control. And if you look at the phenology model and when they were spraying their insecticides, a lot of the problems this particular person was having was that they were just spraying insecticides when codling moth was not active. And so in this case, we've been finding that tree fruit growers in Washington are wasting about $200 an acre on codling moth control. And if they used phenology models a bit more effectively, they could be reaping huge savings. So we'd like to bring this kind of technology to Bmsb. The final 2 things I'm going to mention are, we have all these states where we're looking at new invasions. We've predicted maps of where we think Bmsb should live. This is Missouri as an example. And my lab has built a tool, and Tracy mentioned this, where you can actually take, if we know the habitat suitability in the area and we want to survey that area, our lab has a tool where you can come in here and say, I want to survey across this area for Bmsb. It's a new region. We're looking for invasive populations. And we have what's called a transportation model that will actually say, if you want to put out 20 traps to collect Bmsb, here's where you should put them to collect as many Bmsb as possible. And here's the roads you should actually take to drive around and collect those traps. So I think we can do really cool things, both from a research end, but also from an outreach end with a DAS system. And I'm not going to go through all these questions, but these are some of the things that we want people to be thinking about. Where and would this system be valuable? Is Bmsb going to continue to be important enough to warrant something like this? And would this set us up to go after other collaborations in the future? So that's all I have, Nick, on that.
Okay, great. Thanks, Dave. I believe we have some poll questions.
And someone just asked on the questions, what are our degree days for today? And I don't know where the person is, but if I did know where the person was, we could calculate that. It's, you know, as long as you know the min and max temperature and the thresholds, you can calculate degree days really easily. And Anne knows what those are. So
For stink bug, though, at least if you have a population that goes into overwintering, and there's some questions about California and Florida for that, but if you have a population that is in diapause right now, they're not accumulating any degree days.
oh yeah, no, I'm sure the number for today is 0, but on any given day, if we know what the temperatures are and the thresholds are, which Anne has worked out and others have worked out, whoever asked the question, we could calculate degree days. But
for codling moth in New Jersey, I believe it's 1.
Yeah.
From January 1st.
It's an important thing to consider if you're not familiar with what a phenology model is, and Anne talked about it yesterday, that, you know, insect development is really, really driven by heat units. So a generation that could take 30 days in the spring might only take 10 days in the hot of the summer, you know, depending on the insect. So that's why we really need to track weather in real time, because the insects are highly predictable, as Anne mentioned, based on what the weather is, but you need to know what the weather is in that given year.
Yeah, and that just highlights these early springs that we've been having. You know, we may see Bmsb activity a little bit earlier, but we don't see reproduction earlier. Or, I mean, we may see it a little bit earlier, but it's not necessarily timed up with plant phenology. And that was a question that we got yesterday about kind of these plant phenology common garden experiments.
She's in Washington State, she said.
Okay.
Okay.
All right, thanks, Dave and Ann. Did we see results from that question, or are we going to? Oh, here we go. Great.
Okay, that's very good. So, very good news. We should just do exactly like we thought. All right.
So now, Kim, are you ready?
Yeah, I'm ready. Let me go ahead and share my screen. Can you see that?
Yes.
Okay. Let me go ahead and put it into full screen. Okay, as Nick mentioned, Objective 2 is refine and customize pest management tactics for Bmsb, particularly with a focus on biological control. And I'll highlight some of the gaps where we are now and where we propose to move forward, you know, if we can get another project or regardless. And Objective 2 is subdivided into 4 components or posed as hypotheses in the proposal. The first one of these is biocontrol strategies can be customized to specific specialty crops in different regions. And the second one is understanding key factors that limit the impacts from Trisulcus japonicus, and proceed to complete a successful release petition to APHIS PPQ that will allow us to expand and optimize the classical biocontrol across the US. The third is continue work on biorational tactics such as perimeter sprays, attract and kill, action thresholds based on traps, and refinements and so on, particularly with an eye toward being able to accommodate or institute conservation of natural enemies into these. And the fourth one is continued research on landscape factors and crop stage that can help to determine Bmsb risk in specialty crops where Bmsb may still be an emerging pest in different regions of the US. So yesterday, after our proposal or the presentations on biocontrol, these were some of the gaps that I jotted down that we still have, answers that we'd like to have that will improve our ability to do some of this, factors that influence our working with that wasn't supposed to move there. Factors that allow us to establish and redistribute Trisulcus japonicus, learning more about the characteristics of the different populations, the different inventive populations, work to kind of speed up the the establishment and speed up the impact that we think they're capable of having. Potential work with Nosema as a pathogen of brown marmorated stink bug is another interesting area that we're just getting going on, and there are a lot of interesting opportunities for carrying that forward. And various other work on the importance of landscape factors. So applying those different gaps to the specific objectives here, or sub-objectives of this overall objective. Number one, biocontrol strategies customized to specific specialty crops. These are some of the factors, some of the research areas where additional work would be very helpful in allowing us to customize these strategies. Additional research on the impact of local landscape and climate. For example, does the local landscape provide sufficient overwintering opportunities for the Trisulcus japonicus, which is an important feature of their biology that we think will give them an early start in the year. You know, we can have a big buildup of population at the end of the year, but if we have high overwintering, that will give the following spring generation a good boost the next year. The competition between Trisulcus japonicus and other native natural enemies, predators and parasitoids. There's a lot we don't know about that yet, and what their impact is on the establishment and spread of japonicus. The importance and the impact of host plant diversity, favored host plants for Bmsb, and or the parasites and other natural enemies. And again, the occurrence and impact of Nosema pathogens. If they have more importance on crops early in the year because the pathogen populations are high early in the season, you know, this could be a factor in customizing the approaches for crops that are where the impact is likely to be seen early in the season, and vice versa. So for the sub-objective number 2, understanding the key factors that impact Trisulcus japonicus and classical biocontrol specifically. We still have a lot to learn now that we know we have different populations in the US, at least 3. We need to learn about whether or not there are significant biological differences among these populations, such as important differences in host specificity and potential non-target impact. Do these populations have associated endosymbionts that affect their biology? And in recent years, we've learned a lot about endosymbiotic bacteria that occur in a wide range of insects, natural enemies as well as pests. And some of these endosymbionts have positive attributes. They can be symbiotic in positive ways with a natural enemy, and others of them have negative impacts. We need to be able to recognize if they're present in some of these populations. Clearly, there's still a lot we're needing to learn about the factors that affect the dispersal and or the retention of japonicus populations. We want japonicus to be able to disperse into new areas, but we also want to be able to retain the japonicus populations near crops where we want to see their effect. So these are two sides of the same coin that are equally important. And then again, the importance of local landscape and climate factors on establishment of japonicus. There are things that we still need to learn about that, as well as competition with other native natural enemy species. The third sub-objective or hypothesis concerns integration of biocontrol and conservation tactics with other biorational tactics. Perimeter sprays, attract and kill, and area-wide programs, and so on. And the research that with natural enemies that contribute to this objective include learning how to optimize the retention of japonicus populations, other conservation methods, such as some of the ones we talked about yesterday, the importance of floral resources around crops, maintaining populations of Trisulcus japonicus adults and extending their longevity, and possibly the potential manipulation of Nosema if it proves to be a pathogen that can be manipulated and possibly used as a biopesticide. It could be another interesting approach. And then finally, the fourth sub-objective, landscape factors and crop stage research that will help determine the importance of BMSB risk in new specialty crops. And here, some of these same factors can be applied to natural enemies. The same factors that help determine whether BMSB is going to be a risk are tied in with the likelihood that Japonicus populations can be retained in the habitat. You know, the higher the populations retained, the less the likelihood that BMSB risk will be a problem in a particular specialty crop. So all of these factors, all of these research areas also apply to this sub-objective. So with that, we can open up for discussion and questions. And there's one item that I would like to correct yesterday. I mentioned previous conversations I had had with APHIS about their willingness to allow redistribution of existing adventive populations from one state into a neighboring state. And I had been given the impression in previous conversations that this is something they were willing to consider. So I checked this morning with Bob Pfannenstiel with APHIS about the status of that and how that might be done. And they seem to have gotten cold feet about that. He says they're no longer willing to automatically grant that without going through the full permit process. This is something that's still possible, but it would require adherence to the existing environmental compliance pathway, which requires a permit and review process. They're very concerned about the precedents that making exceptions would involve, and they don't want to get themselves in a situation where other groups will come in and say, well, this organization or this group got permission to do something out of the ordinary, and why can't you extend that to us? They don't want to be in that position. So this is a bit of this will delay the redistribution from one state to another, but it's not a critical roadblock because these populations are going to spread on their own, and we can still help them spread from one state to another by working with cooperators in states that have the Trisocus japonicus populations. So it will just require a bit of extra work. And with that, I didn't have any specific questions to put up, but I don't know, Nick, whether you were going to put up a list of survey questions.
Yes, here we go.
Okay, good.
Great, Tracy, when you're ready.
Okay, and you can see my slides, Nick?
Yes, perfect.
Okay, very good. So the third objective is associated with implementing area-wide management, and we can kind of think of this as like a capstone project almost, based on what Anne and Dave and Kim have already described. So the objective itself is to implement area-wide management using biorational tactics and decision support tools over large contiguous patches of farmland with specialty crops persistently affected by BMSB, transitional hosts, natural habitats, and developed areas that provide overwintering and food sources for BMSB, as well as collecting data on economic analysis of the management cost and adoption of tactics by growers. And so I just presented on the Mid-Atlantic area-wide project, and we can use this as a guide on how to set something up like this. Again, this was our approach in the Mid-Atlantic, and obviously we don't have the same scale of crops that some regions do, and we certainly have a mosaic of landscapes typically. So again, as you've heard through the presentations by Anne, Dave, and Kim, we have to think about customizing per region and the type of crops that are integrated and that sort of thing. But the bottom line is that we're going to look at, again, the goal is to reduce landscape level pest pressure such that we have reduced populations invading some of those very susceptible specialty crops. So the other piece of this, of course, and we heard Kim talk about some of the things that we need to continue to improve, and that is our within crop IPM tactics, those biorational or biointensive tactics that we can use to reduce those broad spectrum insecticides that aren't necessarily going to be that friendly when we think about some of the landscape level approaches that we can take. Things like our trap-based treatment thresholds, attract and kill, border sprays, all of that can be used to improve management of BMSB, but also enhance, like I said, some of the landscape level factors that we can use. And so, again, when we think about BMSB, we can't just think about what's going on in the apple orchard, because next door is a cornfield, there are native woody hosts, invasive trees like tree of heaven, all of which can provide populations. So as Kim and others have described, we need to think about how we can enhance and integrate our native natural enemies for BMSB, as well as things like nosema that can operate in those non-sprayed, unsprayed areas, wild host habitat, oftentimes where BMSB populations build up and ultimately invade. We also can use and integrate our classical biological control agents like Trisulcus japonicus. And again, based on the information that's being generated, we can optimize our retention of TJ, we can increase the overall impact. But all of this, as you can tell from objectives 1 and 2, will build on this objective. Additionally, you know, I talked a little bit about this. We still have other critical research needs for area-wide management, things like the impact on abiotic conditions on overwintering survivorship and seasonal population dynamics. But at the end of the day, we'll think about this in a customized way with different crops, different geographic regions, different natural enemy complexes. We have to customize around that and incorporate the region, the crop, the natural enemies, and really create site specificity and use those decision support tools across this area-wide management site to reduce populations so that they are not getting above sort of these, you know, these threshold levels where we know we're going to get damage. That's the ultimate goal. Reduce these populations, these invading populations into vulnerable specialty crops by reducing them at a landscape level. So that's really it. I'm going to stop sharing. I wanted to keep it brief so that we have more time for discussion.
Are people able to see the slide that I posted?
Yes.
It's kind of a, this is kind of some background for the poll questions, so you may want to read that first.
Okay, just to sort of finish this up so we can get into the discussion, there's just the last objective that I wanted to cover briefly was on extension outputs. And I'm not going to read the objective again, but really what we're trying to do is deliver, you know, customized BMSB management programs to specialty crop industries and support the industries in adopting sustainable IPM tactics. So Dave touched on this, but a really powerful aspect of an online decision support system is the ability to connect with users and provide outreach information that is reflective of the time that they're seeking the information and also potentially the region. And so that is it's a research objective, but it has a strong outreach component. And similarly, the area-wide management gives us the opportunity to implement management at the landscape level in cooperation with growers, consultants, and other stakeholders. And this is a powerful outreach component as well, because we can utilize field days at these area-wide management sites, and by working with key stakeholders, you know, we can increase our influence on industries. We also have a lot of other more traditional and also some novel extension products in mind. So one good idea I think Tracy had was the hackathon event to challenge some of our upcoming professionals on generating new outreach products. Of course, we plan to upcycle stopbmsb.org and have continued engagement with the Northeast IPM Center. those have been very successful relationships, and the Stop Bmsb webpage, as we heard earlier, is a huge resource for Bmsb information worldwide. And for customization, we're also relying on traditional communication channels at a local level through extension standard protocols. And also I've really enjoyed some of the coordinated extension products that the projects have produced, and I think the stakeholders really have appreciated those as well. So continued production of those types of products. And of course, continued stakeholder involvement and inputs similar to what we're doing today, but hopefully in person soon. And also providing trainings for using the online decision support tools. And we've also talked about, having our meetings open to a broad audience of stakeholders to sort of incorporate their inputs as well. So there's a few polling questions on this section, and then I think we have time for discussion, and what we're hoping for really is, if you're a stakeholder and you're watching this, what are we missing? Or even if you're a researcher, what are we missing in these components going forward? And any other suggestions for us, I think, or, areas where we may be off base. That's all fair game. So.
Hey, Nick, can I bring up sort of a topic and a question that would involve Kim?
Please.
Okay. Hey, Kim, can you explain what our options are again for Trisulcus japonicus, just as you see it? I was listening, but I wasn't quite sure. So I just want to make sure everybody's clear on what our options are if you don't have it in your state. What can we do?
Okay. APHIS will not they will not authorize redistribution to a state where Trisulcus japonicus has not been officially reported. But they do not concern themselves with what happens, with what states do within their own borders. So that's why individual states have been able to redistribute, and they can redistribute right up to their border. And in Oregon, for example, some of your releases in Oregon were way down near the California border, and Californians were, eagerly waiting to see whether, how long it took them to get over the border. I mean, this approach can easily be taken. It may not be quite as fast as asking APHIS to just say, can we request this from our neighbors and have them send it to us and be told yes. APHIS won't do that, as it turns out. But perfectly free to get cooperators in Virginia, for example, and have them work directly with you folks in North Carolina to make releases right north of the North Carolina border on windy days where the wind's blowing south. It'll take a little bit longer, and it'll take a little bit more effort maybe than letting Trisulcus japonicus move on its own, which I'm confident it will eventually do anyway, but we do have ways of speeding it up even without APHIS's cooperation. And then, of course, if we can, when the petition is submitted very soon now, I've been encouraged to include both adventive populations and our quarantine Beijing population in the same petition, so that if we do get permission through that petition, it could conceivably include everything.
So Kim, this is no change in their stance that they've had for the last couple of years.
Pardon me?
This is no change in their stance that they've had a couple of years, but with this.
No, it's not really a change, but in conversations I've had with them, I thought I heard signs that they might be willing to relax their standards a bit for state to state redistributions. And now they're not willing to do that after all.
Can I ask another question, Kim?
Sure.
If somebody, we've obviously, like, you've been able to import particular adventive populations into Newark, but if Maryland wanted to give me some TJ from their colonies, we still couldn't do that, correct?
Technically,
even though we both have the same.
Right. Yeah, that's right. You both have adventive populations, and it's probably the same population, but technically, APHIS would not authorize that. They might be willing to to
Yeah.
overlook it. Especially if you didn't ask them for permission, but it wouldn't be a big deal probably.
But at the same time, yeah.
Yeah, they don't want to be in a position of authorizing somebody to not follow their procedures.
Mm-hmm.
I have a question for Dave Crowder. If you can go that route.
I'm here.
So Dave, what weather stations do you have the option of accessing? Can you access other states' weather stations or private weather stations, underground weather stations?
All of the above. So within Washington, we have our own mesonet of stations owned by Washington State University. There's also something called AgriMet, which is a Pacific Northwest organization. They have weather stations we can access. We can also get data from what are called national gridded weather providers. So if you go outside on your phone and click the button, it tells you the temperature. That's a gridded provider. We have access to that. And this year, we've started working with private companies that have installed their own weather stations. And we can run our system off weather stations that users might have in their very own orchard. So anything that provides weather data, we can run it through. Obviously, if it's a private organization, we need to get permission, but we have enough options of free weather sources that I think we can do this anywhere in the country pretty easily. Did that answer it, Jim?
Yeah. So I know one thing in North Carolina, what our weather station people or the climate office is sometimes concerned about. They don't want us to access weather stations that they don't have control of just for quality control issues, which kind of annoys me a lot of times.
Within our system at WSU, we have some pretty intensive quality control routines that can flag errors or can flag things if a physical station goes down or if a grower's connectivity goes down, and then it automatically kind of defaults back to a gridded national product, which basically never goes down because those are run by big companies on the cloud. And so we have backups and quality control routines within a decision support system to be checking and validating weather information, just like you said, to make sure it's always up to date and accurate.
Okay.
Can I ask a follow-up question to Dave?
Yep.
So I'm just curious. I mean, obviously you guys have had that system for a long time. What percentage of your grower community relies on that? And how long did it take to get them up and running kind of once they kind of understood the tools?
So the system evolved kind of out of Jones's research program, in a way. And over time, as Vince's lab moved forward on insect models, he also collaborated with pathologists, economists. So the tree fruit system in Washington right now has 43 different models on it, 13 insect models, like 5 or 6 pathogen models, and a lot of horticultural models. So it took 15 years to develop that system completely, and it's still we're adding new features every year. It's being used on over 90% of the tree fruit acreage in Washington to a tune of about $20 million of savings. That's estimated by the growers. They say it saves them between $75 and $200 an acre. That's going to depend a lot on the system, what your insecticide applications are, the value of the crop, et cetera, how valuable a system like this is. But it's pretty cheap, it's good information. So we do have really good market coverage. And we just developed a new system for potatoes. And there's only about 300 potato decision makers that I can tell in Washington, but we already have 1,000 people registered for our site. So, and that's being launched this year. So I don't know. I think as we get more and more turnover of people that manage agricultural industries, we get more and more people that are technologically savvy that want info on their phone or tablet in the field. And I think, people are ripe for this kind of info. They want this kind of info. So they, if we can get them in the right way, they're going to use it. But it is going to take time. I will say we're not going to come up with a system in year one of a new project and get full adoption. It has to be what we're talking about, customized, tailored extension, as you all know, is not an overnight process. It's going to be an educational effort and kind of constant reinforcement to get people to use it.
Sure, but it's great to hear. Yeah, it's just nice to hear the high adoption rate. That's great.
Yeah, it does have a very high adoption rate in Washington.
Yeah. What are you drinking, Dave?
Coffee. a huge thing of espresso that I probably shouldn't in a mason jar full of espresso, Tracy. I have 3 young children. That's what I need every morning. Are there any, like Nick said, stakeholders that are out there that use decision aid systems? Are there any features that we mentioned that people, it sounded like from the poll that people are interested in these ideas. I think it's hard to have a discussion like this, Nick, with 60, 70 people out there. I don't know if anyone has thoughts in the chat or anything, we'd love to hear them.
There's a comment from Juliana in the Q&A that's kind of relevant to the discussion. She says, what about growers in states that are used to using other decision support systems like MSU EnviroWeather and the Cornell NEWA system?
Yeah, I think we need to think about, if we're developing this, how we either incorporate with things that already exist, or do we want to build, I think there's a value of having a coordinated platform and, that growers in different places kind of can see the same thing. But I do realize that there are different systems out there, like the MSU system is completely different than like the Washington system, for example, like EnviroWeather at Michigan State, as far as I know, has information on every one of their crops all in one place. Whereas like a tree fruit decision aid system just is really focused on time sensitive. So kind of they're all different models for what this could look like.
Yeah.
Dave, to follow up on that, would we be able to link, if we develop something specific for BMSB through the DAS system, would we be able to link it through these other programs like the NEWA or EnviroWeather? Like, so if they could create like a drop down or a tab for BMSB, it could link them to, we could link in weather stations from that state or that region and link it into the model that's run through Washington State?
Yep, absolutely. Yeah. Yeah, we are, that's kind of how this works in a way. Like we are pulling in so much information from a lot of different places at a lot of times. And that's kind of how the system has been designed to like provide that flexibility. So actually, let me show you just one screen. This is actually just for tree fruits, the network of collaborations of data that we're pulling in just to run models for tree fruits. So the user sees the phenology model, but they don't see all this other stuff. But Anne, like you said, we could be pulling in data from weather stations, systems all over the country, synthesizing it in one place and then spitting it back out. So that's how it's designed to work. But yeah, like you said, yeah, we could have a link on EnviroWeather. Some of those sites, I hope people understand what I would call the difference between a calculator, though, and a decision support system. It's not that hard to track degree days, for example. That can be done pretty easily. What is hard is to forecast ahead in time, provide recommendations, tell people when those timings of stages are going to happen in the future. So then you take it from reactive management to proactive management. That's what's difficult. Putting a calculator up on the web that just says, here's what your degree days are today is not a decision support system in my mind.
Mhm.
It has to lead them to a decision, not just, hey, here's one tiny piece of info.
Which is exactly what Sharon Coleman's comment is. She says, working with nursery growers who in turn reach people is one approach. However, one nursery owner that I showed how to get info from the Tri-State Pest Management Handbook, his response was, I don't have time to work my way through all that. I even put a link on his desktop, sometimes just a phone number or email to ask the question, how do we make it really easy? That is the challenge.
It's absolutely right.
Yeah.
How do you take a lot of complex information and spit out the one or two things that the grower needs to know to make that time-sensitive decision? Is not an easy process, but that's the goal.
And that's where crop consultants and educators are going to be really critical in all of this. It may not be that an individual grower is going in and tracking their site. I mean, we certainly have growers here who do that, but in general, most of them are getting information from the newsletter that our IPM program puts out. So they're saying the IPM newsletter is kind of summarizing data by region and saying, okay, the timing is, next week for this pest and this pest and this pest, and look on the horizon for these pests. So it may not work where each grower is going in individually, but it could be that it's a mix between consultants and extension educators and individual growers.
Absolutely. And that is what we see in our system. We have like what we call super users, people that are consulting tons of sites. We have the individual user that's managing one orchard. We have an independent consultant that maybe has 3 farms they're looking after, and et cetera. We have big companies. So you will find different users in a thing like this that you need to target in different ways. But what Ann mentioned is important. The decision support systems, we can build a framework to deliver information all over the country, but without the site-specific, educational, trusted people, it's not that useful. I could build a system to deliver degree day information in New Jersey, but I don't know anything about New Jersey. Those growers don't know me. Ann needs to be out there talking to them and showing them what this means. So there's kind of a scalable part, and then a part that will continue need to be customizable and require on the expert on the ground expertise that this team excels in.
One thing we didn't really talk about, Dave, was how to integrate natural enemy phenology into the decision support to sort of give growers guidance on, how to avoid having adverse impacts on their natural enemy community and get better benefit from biocontrol.
I know in the system we have in Washington, we have models for natural enemies. And when a user is looking at codling moth, for example, we present information that says, here are the options of the pesticides you can use right now, and here's what their impact is on natural enemies. So there are ways to incorporate that. And I also think as we learn more and more with Kim's group and others about where releases might be successful and where, the timing is good, that the phenology of the Trisilicus matches up with Bmsb. We could even be developing spatial tools that say, here's the areas where there really is high overlap, low overlap, where we think kind of releases will be successful or not successful. So I think there's a lot of kind of customization we could do on those fronts. But yeah, I agree. I mean, the whole point of a decision support system is to provide kind of a holistic context of how the grower needs to think about things. Mm-hmm. So natural enemies are a big part of that. And I think Tom and others have, and Ann too, mentioned that some of the more premium products, the IGRs, the things that really matter about getting your timing right, that's where we can really be selling this system. If you're going to be spending a lot of money on an IGR as opposed to a pyrethroid, you want to make sure you get it right. And so does the company selling you the pesticide, because that's a premium product compared to something you can just spray for $10 an acre.
Right. Well,
Is that it, Nick?
well, I'm not seeing a lot of
Yeah.
comments coming in.
I have a quick question from the polling standpoint. We were going to ask that one question about people's relationship to the Bmsb SCRI project again, in case anyone came after the break. Do you want me to post that again real quick if people could vote? Then we can parse out the data according to different groups.
Yeah, I think that's pretty important.
Okay. So this will be our last poll. People could, they've seen it before, so I think I'm gonna guess Peaches wins out again.
Fortunately, you got about a 2-hour window to eat a peach while it still tastes good. So
Yeah. Maybe people's taste changes during the day. This is good. A lot more people voting on this one. It's one of the most important questions for us to be able to categorize the data. Thank you for all the input. We're up to about 72%.
And I'll just tell you all that I find a stink bug in my house every single day, and I put it in a little pill bottle in my freezer, and that's where they live till spring when I throw them away.
okay, you can keep that poll up, David.
Okay.
If we're done, Nick, I just had a few concluding remarks.
I'm done. Thank you, Dick.
Okay. Thank you, Nick. I just want to, if there's any stakeholder advisory panel members out there that have comments on any aspect of the program during the last 2 days, please raise your hand and speak if you'd like. I take it, I know there's not a lot of takers on that right now, so I'll just go ahead, and I just wanted to thank the people who helped put this on, especially the Northeast IPM Center. Kevin Judd and David Lane and Nancy have all been really helpful behind the scenes. You know, Kevin has been up for the last couple of nights answering emails at 10 or 11 at night, so I appreciate that. Also, Emily Ogburn and Steve Schoof in my lab, they've been really important in terms of putting together data, and I encourage you to visit the Stop Bmsb website and download the 2020 annual report. There's a lot of good information in there. And also, I forgot to mention Deb with the Northeast IPM Center. She's been great. She gets the right people involved, and she just really creates a good atmosphere of camaraderie. So that's been really nice to work to put this on. And then, of course, all the PIs, you guys have been great. Every time I ask for something, whether it's to participate, give a talk at this presentation, or ask for annual report information, everybody's prompt. I mean, I guess Dave said it best. It's a great group of people that have been working together for a while, and there's a lot of good synergy here. So that's all I had to say. Yes. Yeah.
Thanks, Jim. I just wanted to say thank you to you for all the hard work and organization and keeping us moving forward. Because it's no small feat.
Yeah, no problem. There's a lot of people helping. So. Okay. I see no reason to hang around here any longer. Here's the last one. Oh, dang, Peaches went out again.
Thank you for all the polling responses, everyone. Thanks to all the presenters and all the attendees.
Thank you, everyone. Nice job, Jim and Nick.
Yes, thanks for putting it together. Jim and-
Yeah, way to go, Jim.
Yes,
Enjoyed it.
awesome.
Okay, I'm out of here. It's just about.
All right.
Take care.
See
Thanks.
you.